And welcome to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. Just bringing you the world's most comprehensive daily space weather content and most detailed solar imagery you'll find in the known universe. These are 24-hour videos from Solar Dynamics Observatory. You might see a very bright and very active sunspot and an X-class flare or two right at the beginning of that video. That's Sunspot 3590, the largest flare-producing sunspot of solar cycle 25. And don't worry, we've got some extreme close-ups of it. We'll be bringing you that and a lot more. It's a prime time to explain how coronal mass ejections and solar flares are completely different phenomenon, folks. If you weren't aware of this, I guess it's a great time to tell you. So, people seem to conflate coronal mass ejections with solar flares, and these are separate events, folks. So, it's a prime example of how we see large solar flares regularly with no coronal mass ejection, and coronal mass ejections all the time with no solar flare. Again, separate phenomenon. Solar flares are photons in the form of X-ray radiation, part of the electromagnetic spectrum, the X-ray portion of the electromagnetic spectrum. Coronal mass ejections are when the sun blasts a large amount of material out of its atmosphere, known as the corona. We've also got some coronal holes, as you can see here, south of our Earth scale in that 24-hour video. We'll talk about coronal holes as well. Let's briefly take a moment here and see what's going on planet Earth. So here's a brief look at Earth. We'll come back to meteorology toward the end of the video. These are the erupting issues. Mount Ibu is exploding. Also Semeru, Merapi, Dukono. Popocatépetl, Santiaguido, Fuego, Revenador, and Sabancaya. As far as earthquakes go, we're still seeing a 7 magnitude earthquake drought, as you can see right there. 7 magnitude earthquake droughts end in large earthquakes. So get ready for that to happen, as it's gonna happen. Largest quake of the past 24 was this 6.3 in the South Pacific Rise early this morning, just before 2 o'clock. Tonga also had a 5.3. That was a depth over 112 kilometers estimated depth. Indonesia had a 5.2. Those quakes were only a few minutes apart there, only about 14 minutes apart. And those are all of the 5 and greater magnitude quakes of the past 24 hours. Next, some more solar imagery for you. Here we've put together that's the SDO 171 angstroms raw imagery with the 131 angstroms 60-minute running difference. So if that's not close enough, here's the equatorial zoom. And here's an even closer view of Sunspot 3590. Like we said yesterday, it's one for the history books. And we've got crown prominences going on at the same time, so it's going to be a great 16 months for space weather. And we've got some people like Bob Lehman expecting to see higher levels of activity in after solar maximum. So on the ramp down, expecting more activity. The highest X-ray output, for example, expecting the largest X-ray flare quite a ways after the solar maximum, which we're expecting around October of this year, 2024. So before we get to any more of that imagery, let's take a look at some stats. The 10.7 centimeter radial flux now at 173 solar flux units. There's the 1 year graph. If you're wondering what a solar flux unit is, it's 10,000 Jansky It's 10,000 Jansky. So that's just a measurement of electromagnetic radiation propagating through space. There is the sunspot number for the past year. The red line, the black line is the radio flux. These are proportional data sets. Radio flux and sunspot number, they move up and down together, and you can expect to see continued higher highs and higher lows for the next 8 months approximately. Moving along to the Space Weather Enthusiast dashboard, and I think they have a misprint here. They're saying geomagnetic storm likely on the 25th as a result of a CME that was released on the 21st. I believe they mean yesterday, the 22nd, but we agree on the timing. So you might have heard us forecast that one yesterday, expecting a mild geomagnetic unrest, mild geomagnetic storm conditions later in the day on the 25th. So there you go. We agree with NOAA. It is fairly rare for us both to be incorrect. Next, the past 4 hours of Earth magnetic moment from space. It's our Geospace Magnetosphere movie. And take a moment to reflect, relax, press the like button, press subscribe if you're new to the channel, do yourself a favor and get the world's most comprehensive daily space weather content right on your YouTube subscription feed. Again, the last 4 hours of Earth's magnetic moment from space. Here are the last 4 hours of Earth's magnetic moment from the ground level. And not expecting much to happen until Wednesday. Yeah, Wednesday. Wednesday, ask Smash staff. Wednesdays are great days to drink soda pop in Texas or in Washington. KP index is at 0.67. There you go. 0.67. That's the average of global geomagnetism. Very much geomagnetically calm conditions. Solar wind is next. There's the data from ACE. Only about 1.5 protons per cubic centimeter, so a very diffuse solar wind and kind of slow at only 349 kilometers per second. Discover showing two different solar wind regimes, where the solar wind velocity is varying between the 460s and the low 400s, and the density also varying there between about 1 proton per cubic centimeter up to about 6. So significant. So like two different solar wind regimes there showing up at Discover. The current conditions are just over 400 kilometers a second and about 1.5 protons per cubic centimeter. GOES magnetometers, they're smooth. It's no space weather coming in, so no rapid gyrations in the outer portion of the Earth's Van Allen belt magnetic fields, the location of the GOES 16 and GOES 18. Next, looking at the heliosphere and the magnetism therein, or should I say herein, and Earth is remaining in a South Pole current sheet at the moment, a South Pole heliospheric magnetic sector shown there in red. It's our top view ecliptic plane field plot. Here's our line of sight field plot. And lots of information depicted there. Photosphere magnetism in grayscale, polar fields in red and green for south and north, and the solar B field, the field going through the magnet, in blue. Next, our line of sight coronal hole plot, and we've got a bunch of both polarity coronal holes. The one that's right in the Earth-facing zone is of south pole orientation. Let's take a look at that in 211 angstroms. So we can expect a mild uptick in solar wind from that in about 4 days, maybe as little as 3. So that is going to change the forecasting, by the way, also, because when you have coronal holes, well, it raises the likelihood of proton events. So that's something coming up here. Again, 3 or 4 days, we can expect a high-speed wind pulse from that coronal hole. And let's move to sunspots. So there you go. There's the uptick in sunspot that we called for yesterday. Pretty much exactly what we said it would be doing. An increase of sunspots of about 60 sunspots. I believe that was almost exactly. I think I said 60 sunspots would be the increase. There you have it. There's another forecast successfully completed by the channel. Now, likelihood of X-class solar flares still remains, okay? So Sunspot 3590 is still very volatile. There's a lot of plasma around it. There's a lot of instability, and the magnetic field shear is extreme. So that's why you can see that 60% chance of X-class solar flares. I tend to agree. So don't be surprised to see more large flares. And again, a great example of some massive flares that barely produced any ejecta, if any at all. So remember, folks, solar flares and coronal mass ejections are completely separate phenomenon. Solar flares are photons. Coronal mass ejections are protons. So before we do that, let's take a look at sunspots from SDO. So there's the magnetogram. And don't worry, we're going to pull in real close to show you that funky series of gyrations in the northwestern quadrant of Sunspot 3590. Check it out. Some funky gyrations happening there. So some rapid magnetic field switching happening right in the upper right corner of that sunspot. There is a bit of a plasma bridge there, so some massive magnetic indecision happening there. Maybe some of your favorite heavy elements being produced in that region. That is an extremely volatile region right there. So there's the continuum. How you like them apples? Some fantastic imagery there from Solar Dynamics Observatory. That is the epitome of a solar flare producing type sunspot. And we're delighted to have been covering it. Didn't look too exciting when it rose. It looked like an alpha class sunspot, but then it rapidly changed as those trailing umbrae became evident. Sunspot 3590 became violent. So we'll probably have another uptick in sunspot number tomorrow, as we'll have a bunch of new groups getting counted on the eastern limb. Also some new groups forming in the west. So if you look down here, there's a new sunspot forming right there. And again, a number of new groups have risen in the east. Not sure if all of those will be counted yet for today's sunspot number. We're expecting another uptick tomorrow, not quite as large as today. Next, we'll look at flares and proton events. There we go. The proton flux here is still flatlined. Baseline levels have been mostly achieved there. And there you can see 3 X-class flares in that's within a 24-hour period. So, and that is the largest solar flare of the sunspot cycle. I thought it was a 6.4, but that says 6.23. Peak flux was around 2235 yesterday evening. And let's take a look at wavelengths such as 131 angstroms. And dude, we've got some sweet coverage tonight. So 131 is the hottest of the SDO AIA wavelengths. It is one of the many species of ionized iron that's covered. Let's actually play that through one more time for you here. One of the many species of ionized iron covered by the Solar Dynamics Observatory. And that was like 2 different spots kind of erupting at the same time there. Here's 94 angstroms, another species of ionized iron. A different number of electrons. Now keep in mind, folks, those wavelengths are not visible to the naked eye, and they're not green. Those are artificially covered by, they're artificially colored rather, and that's just to identify the different wavelengths. 94 angstroms is not visible to the naked eye. It's part of the extreme ultraviolet spectrum. And you wouldn't want to be viewing those wavelengths, as they are harmful to your eyes. So here are our extreme close-ups. First, the 94 angstroms. and then on to 131. That is a 24-hour video. Those are 30 frames per second, 131 angstroms, Solar Dynamics Observatory. Again, likelihood of large solar flares remains. X-class flares are still likely from that sunspot group. Anyway, let's move on to... Oh, we've got some even more extreme close-ups. All right. Well, that's as close as we're going to get. That is pretty sweet. And let us know in the comments what size television you view the videos on. That is some pretty sweet pixels. Those are some pretty sweet pixels, I should say. Not too bad. It's been a fun few days for space weather. Looking down the barrel of a gun, son of a gun, son of a psst, getting paid, getting psst. All right, so what's next, folks? What's next? Well, a star chart is next. So shall we show that? Yeah, we shall. So that's what's going on over Lehigh Valley, Pennsylvania. We've got a full moon coming in a day or two. There's the moon rising near the star Regulus. So if you see a bright star near the moon, that would be Regulus, part of the constellation of Leo. Next, our solar system forecast. We've got the location of things today, and there's the location of things in 1 week. Earth is all alone on this side of the solar system. 0 of the other 7 planets are present over here. Next, our astronomy photo of the day, and it's the Pencil Nebula, part of the Vela complex, and believed to have erupted about 11,000 years ago. The Pencil Nebula and its supernoval shockwave is the astronomy photo of the day. apod.nasa.gov if you want to check it out yourself. apod.nasa.gov. Not half bad. And the colors are showing different chemical spectra there. The blue is oxygen and the red is hydrogen. Next, CMEs. I guess those are kind of important, right? So yeah, that's a thing. Let's cover those. And it's been very mild. We don't even have any custom videos today for CMEs because there's barely been any action. So there was one on the way to arrive on Wednesday later in the day, but since then things have been chill. A prime example of how you can have X-class solar flares and practically no ejecta headed Earth's way. There are our Soho Lasco coronagraphs, the C2 on left and the C3 on right. You also see Mercury there on the C3. And again, CME action has been quite mild indeed. So we've also got stereo A, and there's not a lot to show, so let's just skip it and move on to look at filaments. Yeah, filaments. They turn into CMEs sometimes. Sometimes filaments grow up to be coronal mass ejections when they blast off, and we've got a few on the Earth side of the disk. Again, we've also got a crown prominence at both poles, a feature that is more typical to see around solar maximum than any other time. So as we ramp up and up and up to solar maximum, we can expect to see more filaments, more CMEs, more coronal mass ejections, and indeed more coronal hole high-speed streams. So, again, exciting times for space weather. Before we get to our bonus feature segment, here are the past couple of hours from the GOES 16 SUVI. That's ionized helium, 304 angstroms wavelength. And here come bonus features. Starting out with satellite charging hazards, we ain't got none. It's smooth sailing for satellites at the moment. We don't have energy. We don't have high energy electrons building up outside a spacecraft or low energy electrons building up. High energy inside or low energy outside spacecraft. We ain't got it. GOES electron flux is still low as the shortage continues, folks. It's an electron shortage, and perhaps that'll put you in your bunker if you feel the need to bunker up over the low electron flux, which has been going on since December. Then definitely bunker up over that. I don't know why you'd have to be spooked of space weather, but if you're spooked of low electron contents, this is the segment for you. Bunker up, folks. Bunker up. Watch out. It's low electrons. Oh, my God. Although it didn't get as low as NASA's forecast. Look at NASA's forecast. NOAA's forecast. It's all over the place, folks. It's all over the place. So, yeah, it's been flatlined for quite a while, as you can see. Anyway, we'll also show the layer where it's measured, which is the F layer of the ionosphere. Feel free to pause the video in this frame if you're not familiar with the distances. The altitudes of different chemical strata, chemical temp. Anyway, here's the ionosphere. It's been a long week, and we've almost reached beer o'clock. So there's the ionosphere, and it's looking pretty nominally. Not very exciting. It's quite chill in the ionosphere. There's the anomaly in megahertz from a 30-day median. And there is absolutely nothing to write home about going on there. Maybe we'll see some fireworks happen on the 25th. But until then, not much expected to change. Here's the whole atmosphere model. That's the free electrons over on the left to about 12,500 miles of altitude, which is the inner portion of the outer Van Allen belt. On the right, you've got usable radio frequency. And it's time to close out the daily space weather video with the latest high-resolution images of the closest star. There's the HMI instrument. And check it out, we've got this plasma bridge still lighting up with some funky magnetic shear. You can even see it there making its way across that umbra. Very funky situation there. Very likely to produce X-class solar flares. Continued to go forward. Exciting stuff for space weather. As far as these new sunspots, that one looks like it's barely beta class. That one there is looking like it's beta class. And that one there is looking like it's beta class also. Now it's time to do meteorology. And let's take a look at Saharan dust. Oh my God. If you're spooked of Saharan dust, it's bunker time for you too. There's a huge plume of Saharan dust making its way all the way practically to Greenland. At the moment, you can see this. That's all Saharan dust right there, folks. That is tamping down weather systems and so forth in the Atlantic Ocean, reducing the likelihood of precipitation. Anyway, some dust in Australia as well. Let's take a look at our air masses. There are the surface winds of the east. There are the jet streams. Shout out to our viewers from the east. There are the central world. Shout out to our viewers from the central world. That's the jet stream over you. Here is the surface wind scenario blowing at you. Next is our surface winds of the west and the jet streams of the Americas. Next, clouds and fog for the Americas. It's shortwave radiation depicted by the NASA GOES Interactive Weather Satellite Suite. Next, snow depth. Yeah, snow depth. So there's where the snow lies at the moment. It's mostly melted here in Lehigh Valley, Pennsylvania. Let's do a quick update here on what the snow's going on in the northern hemisphere. Here it is. And the snow extent is actually kind of low at the -1 standard deviation for normal. Snow water equivalent at the +1 standard deviation for normal. And the snow mass balance, not including mountains, is right in the middle of the range. So if being kind of average freaks you out, then, well, average snow, well, it's time to bunker up. Next, our weather.gov site. Yeah, weather.gov. It's where to get your weather warnings if you are concerned about your weather warnings. Weather.gov, the National Weather Service homepage. And here come some forecasts. First, we'll show the pressure and precipitation based on the GFS 72-hour model. There it is. And we've got some high winds coming, so next the surface pressure and 10-meter winds. So again, some strong winds coming. They're going to make their way down the Rockies. And it looks like Colorado is going to be largely spared. Maybe because there's so much hot air. It's the hot air capital of the world, folks. So I suspect that maybe all that hot air is going to be preventing the wind from making its way through there. The hot air capital of the world, folks. Colorado. Although not everybody that's in Colorado spouts hot air. Shout out to Scott McIntosh, somebody who does accurate solar forecasting. Next, temperature anomaly forecast in degrees Celsius. Wyoming will largely stay cold, at least in the western part of the state, and we'll have some major warming in the western Mississippi Valley, the Great Plains. Temperature anomaly forecast in degrees Celsius is what we're showing. And next, the culprit, the 250 millibar winds, also known as the jet stream. There's your GFS 72-hour jet stream forecast. We'll have a doubled-up jet stream. One for Canada and one for the U.S. Shout out to our Canadian viewers. Next, lightning. And we do have some lightning off the Atlantic coast. Quite a bit, in fact. Lightningmaps.org is where to go next time you hear thunder. And do we have some terrestrial strikes? South Carolina. Lightningmaps.org. We'll close out with U.S. Doppler radar, clouds and fog, and water vapor. So there's the full 50-state view. Here's a lower 48 view. There is clouds and fog. And there's the water vapor map. Here's your recap. And here's me tipping my cap at you, the viewer. So thanks for tuning in. Once again, don't forget to press the buttons like and share, etc. Visit our links. Thanks to everybody who has. Thanks to the Smash team especially. And we'll see you next time, like tomorrow, with more of the world's most comprehensive daily space weather content. Thanks for tuning in, and may that solar wind be at your back.